Hi folks, and welcome to video number 178. This one is on trigonometry, the exact values. Now this is all non-calculator stuff. Never used to have to do this in the world of trigonometry, but now you do. And its keywords are trig values and undefined. So the trig values are the exact trigonometric values that you would need to know. And I'll obviously go through that in this particular video. They're things that you need to learn. They're numbers. And undefined means it's a mathematical error. You can't have that as an answer. All right, so we use the word undefined to say that there is no answer to it mathematically. Right, it's not mathematically possible. Now the method states there are a few ways to learn your exact trig values. One way, of the last one that I've written there, you could memorize them. All right, I've never bothered to memorize them because I know I can work them out. All right. Now, there's two ways of doing it. I think that learning the two triangles way is a nice way for higher students to remember it, and the finger trick is a nice way for the foundation students. Now, you could obviously, you choose which way you understand best, all right? But I found that that seems to be the way that people remember them, mostly because you understand trigonometry a lot more by learning these two triangles. This is just kind of a bit of a trick, all right? But I don't mind you using it. You're still going to be able to get your answers. It's absolutely fine. So, learn these two triangles. Now this triangle here is what we refer to as the 2 by 2 by 2 equilateral cut in half. Okay, so we're not interested in that value there or that one there. That becomes 1. Okay, and what we then use is a bit of Pythagoras to work out that side length there. Okay, and that side length there would be 2 squared, or the square root of 2 squared minus 1 squared, which would be root 3. Okay, you could just remember that is root 3 if you wanted to, right? There's our 90-degree angle. Now, if there's an equilateral cut in half, then that's 30 degrees, and that's 60 degrees, because the equilateral triangle's got 60, 60, 60 in it, right? And you can use this to get your trig values. I won't show you all of them, all right? But you can use it to get your trig values. I might show you a few. So let's say that we wanted sine of 60, all right? There's our 60-degree angle, right? It's all about SOHCAHTOA, understanding right-angled triangle trigonometry. So SOHCAHTOA, all right? Now, opposite sine of 60, so SOH, that's the bit that we're interested in. Sine of 60 degrees is equal to opposite over hypotenuse. That's what that bit of our SOHCAHTOA acronym tells us. Opposite over hypotenuse. So root 3 over 2. There's our trig value. Done. We found sine of 60. Okay, that's it. If we wanted, let's say for example, tan of 30. All right, so we could get rid of that a sec. So if we wanted tan 30, there's the 30-degree angle at the top of this triangle here, and that's opposite over adjacent. So what way would it be labelled? If that's the angle of the 30 that we want, that's the opposite and that's the adjacent. So tan of 30 is opposite, which is 1, over the adjacent, which is root 3. Okay, now this is why I think it's a higher thing to understand, right? You can't have a root number on the bottom, all right? So what you do is you change that root, you get rid of that root by rationalizing denominator, which is a skill that I have shown you in the higher section, and that means just multiplying by root 3. Okay, so multiply by root 3 and multiply the top by root 3, you end up with root 3 over, and then root 3 times root 3 is 3. So that's our tan 30 is root 3 over 3. You probably get away with putting 1 over root 3 at foundation level. I don't know for certain actually, but yeah, there you go. That's it. I could carry on with that for all of the sine 30 cos 30 tan 30, sine 60 cos 60 tan 60. Okay, I do that for all of those, right? But I'll just let you do it, all right? Because it's all about practice and understanding it. So it all revolves around this. Now this other triangle here is a 90-degree angle here at the top, and it's just your 1 by 1 right-angled isosceles. Okay, now that means that that's 45 degrees, and that means that's 45 degrees. So it doesn't really matter what you label what here, because they're both 45 degrees here. This one's definitely the hypotenuse though. Okay, now again we can use Pythagoras to work out the hypotenuse length. 1 squared, or square root of 1 squared plus 1 squared, 1 squared is 1 plus another 1 is 2, so the square root of 2 is what that length is. Okay, again, that's just using Pythagoras, and again, that's why I like this way of doing it, because you have to understand Pythagoras and you have to understand trigonometry to understand this way of finding your exact trig values. Again, we just use SOHCAHTOA here, so let's say we want cos of 45 this time. All right, so adjacent over hypotenuse, that's going to be, that's our A, that's our H. Okay, if we say that that's our 45-degree angle, we could say that one was, but it'll still be the same thing. So cos of 45 is equal to adjacent, which is 1 over hypotenuse root 2. And again, we just have to rationalize that denominator, which will become root 2 over 2. All right, that's that. That's all I'm going to go into on these two triangles here. Did 3 examples for you. Could go on for a little while. Could take ages. Learn those if you want, or use the finger trick. You just got to remember this. So here's your hand. Okay, here's your 90. Let's get my pen out of the way. There's your 90. There's your 60, your 45, your 30, and your 0 degrees. You get more values out of this, right? Which is quite useful. So to find sine, any sine value of 90, 60, 45, 30, or 0, you got your fingers below. Square root of the fingers below over 2. Okay, so the square root of the fingers below. So if you want sine of 90, so there's 90. How many fingers are there below 90? 1, 2, 3, 4 fingers. All right, as long as you've got a normal hand. 4 fingers below the 90 degrees, and the square root of 4 is 2. Okay, so that's going to be 2 over 2, and 2 over 2 is 1 whole. So sine 90, right? If I write that one down, sine 90 actually equals 1. All right, because that's root 4 over 2, and root 4 is 2, and 2 divided by 2 is just 1 whole. All right, it all sounds complicated, but actually pretty simple when you get used to it. It's quite a nice little trick. And if you want anything cos related, let's say you wanted cos of 30. All right, this one's about the fingers above. So there's our 30. Don't change these. Always have those 90, 60, 45, 30, and 0. There's our 30. For cos, it's all about the fingers above. So there's 1, 2, 3 fingers above. Right. And then that's root 3 over 2. Okay, so root 3 over 2 is what cos of 30 is. So you write that down. Cos of 30 is equal to root 3, because that's the number of fingers there are above in a square root, and then that is over 2. Okay, so all over 2. So sine and cos are both over 2. Sine's all about the fingers below, and cos is about the fingers above. And then the tan is about the square root of the fingers below divided by the square root of the fingers above. So if you wanted tan of 60, for example, there's 1, 2, 3 fingers below. So tan of 60 is equal to the square root of 3. Okay, and then the fingers above will be the square root of 1, and the square root of 1 is just 1. Okay, so root 3 over 1, which is just easily written as root 3, because anything over 1 is just itself, isn't it? So there you go, tan of 60 is root 3. Have a play around with it. All right, I think that's a nicer, easier way to get your your trig values pretty quickly. All right, now I've taken a fair while to explain all of that, so we'll just have a go at doing a few questions to help you further understand it. Find the exact values of sine 60. So sine 60, if we look at the finger trick, let's use the finger trick for each of these, because I think it's just easier. So sine 60, might have done it already actually, I think I did in the other triangle, but showing you the finger trick here. Square root of the fingers below, 1, 2, 3 fingers below the 60, so that's root 3 over 2. So that's equal to root 3 over 2, right? Cos of 30. So cos of 30, remember it's all about the square root of the fingers above. 1, 2, 3. All right, that's root 3 over 2. It's the same thing as sine 60. Okay, you can always check these things on a calculator as well. If you just type in sine 60, you'll see that it gives you root 3 over 2. Okay, tan 45. So 45 is there. This is all about the square root over the square root. So 2 fingers below, 2 fingers above. So that's going to be root 2 over root 2. Okay, and whenever you've got something divided by itself, that's just going to give you 1 whole. Okay, so tan of 45 is actually 1, right? Yeah, I'll just show you what I mean by checking on the calculator actually. So bring that in. Oops. Tan of 45. Yeah, that's the last one we did. Tan of 45, 1. Right? So you can see you just check any of those. Cos 30. Right? Root 3 over 2. Sine 60, be the same thing. Type that in. Right? But you're not allowed to use calculator on these. I'm just showing you just so we can check. Now cos 45. Cos 45, fingers above, 1, 2. So root 2 over 2. That's what that one equals. Can't do anything to simplify that. Sometimes you can simplify them. Just check that you can or can't. Tan 90. So there's 90. 1, 2, 3, 4. And then we're dividing by 0. There's no fingers above tan of 90, right? So if we're dividing anything by 0, that's not possible. We can't divide by 0. So that one's actually going to give us undefined. All right, and what happens on the calculator with that, if you see what if I type this in, it'll just come up with maths error, right? And that's where we can write undefined, right? There is no answer for that. And that's because on the graph of tan, that's where the asymptotes are. If you've seen the trig graphs video that I've made in the graph section, you'll see what I'm talking about there. And then sine of 0, sine of 0 is 1, 2, 3, 4. That's going to be 4 fingers above. That's root 4 over 2. All right, so sine of 0. No, sorry, sine of 0. That's no fingers below, is it? 0 fingers below. So that's going to be 0 divided by 2, and anything divided, or 0 divided by anything, that's going to be 0. Okay, so that's, no, hold on, is that right? What am I talking about? Fingers below, that doesn't make sense. Square root of 0, let's check this one. Sine 0 is 0, yeah, what am I thinking about? Of course it is, yes. No fingers below, yeah, anything divided, yeah, 0 divided by anything, it's always going to be 0. Right, so hopefully all of that makes sense. It nearly didn't to me there, but now it does. We'll carry on with this because this is all we've got. It's just finding these exact values. Like I said, you could write a table out of them, learn the table values, and you'd be fine. And you just remember them. So sine 30, let's have a look at sine 30. So fingers below, we've got 1 finger below, so root 1 over 2. Root 1 is 1, so that's 1 over 2, half. Okay, plus, let's just write that out over here. So that's 1/2 plus cos of 0. So 0 is there, fingers above, 1, 2, 3, 4. There are 4 fingers above, so that's root 4 over 2. Root 4 is 2. 2 over 2 is 1 whole. So that's just 1/2 plus 1 whole, all right, which is equal to 1 1/2, or 1.5. We put 1 1/2. There you go. Better calculations with them. All right, that's all we're doing there. Now, cos of 60 is fingers above, so there's 1 finger above, so that's going to be root 1 over 2, because everything's over 2 there, isn't it? And that's going to be 1/2 again. And then minus tan of 0. So that's 1/2 minus tan of 0. Fingers below is 0, and then divide it by whatever, it doesn't matter, it's just going to be 0. So 1/2 minus 0 equals 1/2, because you're taking away nothing from the half, so that's just 1/2. All right, so you might get some nice calculations like this. Now the third question, all right, I'm not sure you'd find this on a foundation paper. You'd be unlucky to. But what we've got here is cos of 30 degrees multiplied by tan of 60 degrees plus sine of 30 degrees. Got to show that it's an integer. That means a whole number. All right. Might have needed to put that in the keywords if you can't remember what an integer is. But an integer is just a whole number. So we're going to get a nice whole number at the end of this. All right. But what is each one of these things? Well, let's work out these values. Cos 30. Let's go cos of 30. Fingers above, 1, 2, 3. So it's awkward straight away. Root 3 over 2. That's our cos 30 multiplied by tan of 60. So tan 60 is the fingers below 1, 2, 3. Root 3 over root 1. Okay. Now if you've got root 1 is just, or square root of 1 is just 1, right? So that bit's okay to do. And then we've got plus. Now I'm going to put that in brackets there because we do multiplying before we do any adding. Right? So that's just to remind me that we need to do this bit before we do any adding. Sine 30 is fingers below that is 1. So root 1, which will be just 1. And then we've already done that one. It's 1 over 2, isn't it? Half. So whatever this gives us, we're going to add a half to it. We're going to get our answer, and it'll be a whole number. And if it isn't a whole number, we just try again. So root 3 times by root 3. If you do root 3 times root 3, you're undoing the root, basically. You're squaring a square root. So that's going to be 3. Okay, and then 2 times by 1 is 2. So 3 over 2, which is 1.5, plus 1 over 2, adding fractions, same bottom numbers, 3 plus 1, 4 over 2, and 4 divided by 2 is 2. Okay, we have shown using our mathematical skills of finding the exact trig values, doing a bit of multiplying of fractions and then adding fractions, we get the answer. Okay, so it could well be on a foundation paper because it is a grade 5 skill. However, it's a bit of a tough one. So I'll do another video on this where you've got to use it within problems. It's tricky and sometimes you doubt yourself like I did on that last question there, in question number 1. But yeah, please do like, subscribe, share, comment, all those things on these videos if you can, because it means more people will get to watch them. And I would like that because I like people to understand maths better. And if I can help more people understand maths, that makes me feel happy. So you'll be doing a good thing. If not for yourself, but for me. Make me happy. Thank you so much for watching. Take care of yourselves. Bye-bye.